In this problem, a cannonball, which we'll refer to as object 1, strikes and becomes embedded in a ship, and we'll refer to the ship as object 2. The problem reads a cannonball with a mass of 100 kilograms, so we can say that M1, the mass of the cannonball, is equal to 100 kilograms, flies in a horizontal direction with a speed of 800 meters per second. So we can say that V1, the initial velocity of the cannonball, is equal to 800 meters per second, and strikes the ship initially at rest. So we can say that V2, the initial velocity of the ship, is equal to 0 meters per second. The mass of the ship is 15,000 kilograms. So we can say that M2, the mass of the ship, is equal to 15,000 kilograms. Find the speed of the ship after the ball becomes embedded in it. In order to solve this problem, we need to understand the conservation of momentum. This means that the initial momentum in a system will be equal to the final momentum in the system. When written out in equation form, this reads m1v1, the initial momentum of the cannonball, plus m2v2, the initial momentum of the ship, is equal to m1 v1 prime, the final momentum of the cannonball after it gets a new velocity, v1 prime, plus m2 v2 prime, the final momentum of the ship after the ship gets a new velocity, v2 prime. Before we can continue, it's important to note the word embedded. This means that the cannonball becomes stuck in the ship, and in other words, the ship and the cannonball will both move at the same speed. This means that v1 prime, the final velocity of the cannonball, plus v2 prime, the final velocity of the ship, will be equal to some unknown value v prime. Again, because the ball becomes embedded in the ship, both the ship and the cannonball will move at the same velocity v prime. This means that we can rewrite our equation as m1v1 plus m2v2 is equal to v prime m1 plus m2. Again, this is because v1 prime and v2 prime are both equal to some unknown value v prime. We can cancel out m2v2, better yet we could cross it out, because the initial velocity of the ship is equal to 0. This means that initially the ship has no momentum. Next, because we're solving for v prime, which will also be the final speed of the ship, we can algebraically move m1 plus m2 to the initial side by division. This means that the new equation will read m1v1 divided by m1 plus m2 will be equal to v prime. When we plug in the numbers, this reads 800 meters per second, the velocity of the cannonball, times 100 kilograms, the mass of the cannonball, divided by 100 kilograms plus 15,000 kilograms is equal to 80,000 kilograms times meters per second divided by 15,100 kilograms. When we do the calculation, this reads 5.29 meters per second, which is the final velocity of the ship.